Hello everyone. I hope all of you are doing really well. So this is basically the part 2 of the video related to ASD board exams. Okay. So the previous video was related to halogen derivatives of hydrocarbon wherein we discussed few questions. Now this is basically the remaining part of the topic. Okay, so we will be discussing more about the conversions and interconversions, direct and indirect conversions in this particular video. So if you like this video, please click the like button and make sure that you subscribe to get periodic updates about the upcoming videos. Okay, so now let's begin. So this is basically the part 2, and again it's going to be pretty much easy because most of the conversions are direct. Okay, so let's see the first question, which says name the reagent used to bring about the following conversion. Okay, so we have the first part, name the reagent used to bring about the following conversions. Okay, so you have bromoethane to ethoxyethane. So what is bromoethane? Bromoethane is nothing but CH3, CH2, Br, right? Now this has to be converted to ethoxyethane. So this is going to be C2H5O, C2H5. So if you could see here, now this is basically a direct conversion. You can see this bromine is getting converted, right? This bromine is getting converted to the ethoxy group. That means this is going to be an ether synthesis, right? So this is basically an ether synthesis. So in ether synthesis, you can use two basic terminologies, right? You can convert it into an alcohol and go for the continuous etherification, or you could do simplified simple Williamson synthesis, right? So what exactly happens in Williamson synthesis? So you have C2H5Br, right? Now this is treated with sodium ethoxide. So I'm going to write here NaOC2H5, correct? And the mechanism is basically SN2, the backside attack, right? So what you can do is simply remove the NaBr, as a result of which you get C2H5O C2H5. Right, so this is nothing but ethoxyethane, or you can say diethyl ether, right? So this is a very simple way, and the strategy is nothing but Williamson's synthesis. Okay, so it's basically Williamson's ether synthesis, to be very precise. Okay, yeah, so I think this basically takes care of the first part. Okay, now let's move on to the next question. 1-chloropropane to 1-nitropropane. So what exactly is 1-chloropropane? So you already know this is CH3, CH2, and then you have a CH2, and then there is going to be a Cl over here, right? Now this is converted to, you can write down CH3, then you have a CH2, correct? And then you have a CH2, and then you have NO2, right? So this is a simple conversion. So what exactly are we going to do over here is we are going to use silver nitrite, not nitrate. Okay. So what happens is you have CH3, and then there is going to be a CH2. There is going to be a CH2Cl. Now this on treatment with AgNO2, right? AgNO2, what happens? This Ag is going to go with the Cl, as a result of which you will be getting CH3, CH2, and there is going to be CH2 NO2, right? Plus AgCl. Simple way of doing this particular conversion, right? So it's very easy to understand as well. Okay. Now let's move on to the next part, ethyl bromide to ethyl isocyanide. Okay, so here it's going to be an isocyanide route. So that means you are supposed to know that the reagent is alcoholic solution of silver cyanide. So you can write down C2H5Br, right, plus C2H5Br plus you can write down AgCN. So in this case, you get C2H5NC isocyanide, right? And plus AgBr. So if you would have used KCN, then you would have got a cyanide over here, right? So it's pretty much easy, a direct synthesis. Now the next is chlorobenzene to biphenyl. Now if you could see here, chlorobenzene to biphenyl is nothing but the series of Wurtzwittig reactions. So this is nothing but a Fittig reaction, right? Fittig reaction is nothing but aryl-aryl coupling. So what exactly happens over here is you are going to take chlorobenzene, right? And this is going to be treated, or you can say coupled with metallic sodium. So I'll be needing 2 moles of chlorobenzene and obviously 2 moles of Na as well, right? So the reaction has to be carried out in presence of dry ether, and you already know the explosive nature or highly reactive nature of sodium can be prevented by using dry ether, right? So what happens over here, it's pretty much simple to understand. You have these two Cl going with Na, as a result of which you would be getting a biphenyl or a diphenyl, right? So I'm going to write here the biphenyl ring. Very, very simple and easy to understand. So let me just label this down. So this is basically the biphenyl, and the byproduct is going to be 2NaCl, right? Simple, a direct conversion, you can say. Okay, so now the next part, the reactions involving Grignard reagent must be carried out in anhydrous condition. Now, what could be the reason? Why do you need to carry out all the Grignard Grignard reactions under anhydrous condition? Now, there is a reason. Let's talk about the Grignard reagent. So, the Grignard reagent is nothing but RMgX, right? And we already know in this case the polarity, if you are supposed to write down the polarity, this becomes delta positive and R is delta negative, right? So let's say if you have a medium containing a proton, so I'm just going to write here HA, right? So Grignard reagent, so this is nothing but a solvent itself, right? Solvent. So I can just write down this is nothing but a protic solvent. Now imagine you are using a protic solvent. So Grignard reagent itself is going to abstract the proton from the protic solvent. So this delta minus is going to take up this H plus, as a result of which you will be getting RH plus Mgx, and Mgx over here and A over here, right? So what happens in the case of water? Let's try to discuss. Let's try to use an example in this case. So let's say if you have methyl magnesium chloride. Now this on treatment, let's say if the medium is hydrated, right? So what happens over here? It's very simple. You can write this as H plus and OH minus, right? So what happens? This is delta negative and this entire thing is basically delta positive. So this CH3 is going to abstract a proton, and as a result of which you will be getting CH4 plus Mg, and there is going to be a Cl over here and there is going to be an OH over here. Very simple, right? So this is basically the reason why Grignard reactions have to be done in anhydrous medium, because otherwise Grignard reagent itself is going to abstract the proton, resulting into the formation of a hydrocarbon, right? So this is basically the reaction. Okay, so we are done with this question. Now let's move on to the next part. Okay, so now we have the conversions. Some conversions may be direct, some conversions may be indirect. Okay, so you have the first conversion. In this case, you have a propene, right? Propene to propanol, right? So in this case, basically what we are doing is converting a double bond into a single bond, right? And so let's see how you can do this. So there are different ways of doing this, but let's see the route which involves halogen derivative formation, right? So I'm going to write CH3CH double bond CH2, right? Now this on treatment with HBr. Okay, HBr in presence of peroxide, hydrogen peroxide, correct? So what happens over here is it undergoes anti-Markovnikov addition. So why are we using anti-Markovnikov? Because we need the functional group to be at the first carbon and not the other carbon, right? So this is going to be H plus, this is going to be Br minus. So I'm going to write here negative is going to go to more number of hydrogens, right? So this is just a shortcut. So I'm going to write Br over here. This H plus goes over here. So what is that which you get? You will be getting CH3, CH2, right? And then you have a CH2 Br, correct? Now this you can treat it with aqueous KOH, or you can also use moist silver oxide. So what happens, this K is going to abstract this Br. So what exactly do you get is CH3, CH2, CH2, and then there is going to be an OH, right? So this is a very simple and very easy conversion, even though it looks little bit lengthy, but it's pretty much easy, right? So this is the simplest way, and obviously we can write down the byproduct as well. The byproduct is going to be KBr. Do not forget to write down the byproduct, right? KBr plus H2O, right? So this is basically a method for converting prop 1ene to propane 1-ol. Okay. Now the next one is benzyl alcohol to benzyl cyanide. Now this is going to be little bit tricky because you have a benzyl alcohol over here, right? So this benzyl alcohol CH2OH has to be converted into benzyl cyanide, right? So I'm going to write here as this is basically CH2CN, right? So if you could see here, there is no direct reaction in which you can convert the OH to Cl, right? So first of all, what you're supposed to do is you're supposed to convert this OH to maybe a Cl, right? And you can use SOCl2 for this particular reaction because the byproducts are very less. In this case, byproducts are actually not there. They are gases. Easy separation is possible. You can use PCl3, PCl5, SOCl2. You can use concentrated HCl in anhydrous ZnCl2. That is Lucas reagent. But the best is basically converting it this way, and then after that you can use KCl. Very simple way to do this. Okay. Now let's see. So you have a benzyl alcohol. So I'm going to write here as CH2OH, correct? And then this on treatment with SOCl2, right? So this on treatment with SOCl2, what is that which you get? You get this OH getting converted to Cl. So you will be having CH2Cl, right? So how we normally do this reaction, we break the bond, you write 1 Cl over here, you break the bond 1 Cl over here, and the remaining SO is going to go over here, correct? So I'm going to write here minus SO2, and then I'm going to write here minus HCl. Very simple. Now this on treatment with KCN, alcoholic KCN, right? So what happens over here, this KNCl go in the form of KCl, as a result of which you will be getting benzyl cyanide, right? So I'm going to write here as CH2CN. Simple way of conversion. A very easiest way of conversion, that's what I'll say, right? Okay. Now we have ethanol to propane nitrile. Okay, so nitrile is nothing but a cyanide, right? So how to write the name of this cyanide? You have CH3, correct? And then there is CH2 and you have a CN. This is propane nitrile and this is ethanol, which is C2H5OH, right? So let's try to begin this. It's pretty much simple. This has to be converted to C2H5Cl, right? And then you can use alcoholic KCN and then move on with the reaction, correct? So now let's see what exactly are we going to do here. So you have C2H5OH, okay. Now this time I'm going to use SOCl2 as well, right? So what exactly you get? Thionyl chloride pyridine you can use, right? So you get C2H5Cl plus HCl plus SO2. Byproducts are there, right? So now what next? This C2H5Cl on treatment with KCN. So this KNCl will go in the form of KCl. You get C2H5Cn plus KCl, right? And this is nothing but the propane nitrile. Very simple way to do this. Okay, then we have but1ene to nbutyl iodide. Now here is something that you might want to understand. Here is something that you might want to note, right? So this is iodide. Now you can say that it is but1ene, so you can directly use Hi peroxide something, but actually this is not the correct way. Okay, but1ene should be converted into n-butyl. That means you are supposed to apply Markovnikov's addition of HBr, and this HBr has to be converted into Hi. Not HBr, sorry. This Br minus has to be converted into I minus by using Finkelstein reaction. That's basically the correct way. Correct. So let's see what exactly are we going to do. So you have CH3, CH2, and then you have CH double bond CH2, right? This on treatment with HBr. Now in presence of a peroxide. So I'm going to write here hydrogen peroxide. You can use benzoyl peroxide as well. So what exactly happens? So we already know, I have already told you, negative more hydrogen, right? So what happens over here is, this is the negative part. It's going to go to CH2 because it contains two hydrogen. So obviously hydrogen is going to go to CH. So what exactly do you get here? You get CH3, CH2, and then you have CH2, and then you have CH2 with a Br. Correct? Now what am I going to do? It's a very simple thing which I'm going to do here is, treatment with sodium iodide, okay, in acetone, dry acetone. Right. So what happens over here is, this is going to be a halogen exchange reaction. So you get CH3, CH2, and then you have a CH2, and then you have a CH2, and then there is going to be I plus, wait, let me just make it proper. Yes, CH2I, okay, and then you have NaBr, right? So this is n-butyl iodide. Very easy technique to do this. Okay. Now the next one is prop 1 into propanol. Okay, prop 1 into propanol. Now you can do it using diborane as well, but let me just explain it using this halogen derivative technique only. So you have CH3 and there is going to be CH double bond CH2, right? So this on treatment with HBr, right, in presence of a peroxide, correct? What exactly you get? CH3, and there is going to be CH2, CH2, Br, right? And then this on treatment with maybe aqueous KOH, right, or NaOH. So you get CH3, CH2, CH2OH, right? So this Br is going to go with this K, and plus KBr plus H2. Very simple and easy, right? So even though it looks indirect, but it's simple and easy. Okay, so this basically finishes off few of the conversions. Okay, so most likely, if you could see here, there are certain things that you might need to know, and for regarding the indirect conversions, that's what I'll say. If you want to convert a double bond into a single bond, what are you going to do basically? You are just going to do the addition reaction. Now if you want to have the halide group or any group at the end, at the end of the carbon chain, then the best way is to go for an anti-Markovnikov method. No direct synthesis is applicable over here. So for example, in the previous question, if you see, I had to convert butene to n-butyl iodide. I converted it into bromide, and rather than directly getting into the Hi, due to the stability issues of HCl, HBr and Hi. Okay, so I'll be putting up one more video of part 3, which is basically few more questions from the end of the textbook. Okay, so I hope you have enjoyed watching this video. If you have any queries, you can put that in the comment section. And if you like this video, please hit the like button. And in order to get periodic updates regarding any new videos, please subscribe to my channel and click the bell icon. Thank you.